Okay, so we're going to finish up our last example and then we're going to talk about word problems. So we've got range, and remember, range is how far down to how far up your graph that's connected goes. And so if you look at this slant right here, it goes slanted in this direction because it's not only moving down, but it's also moving in the right direction. So we want to keep those two directions in mind when we start talking about range. If you look at this part of the line, it is slanted up because as your graph moves up, it is also moving to the right, which is causing that upward slant. So if we look at our two questions for range, remember it's how far down does your graph go? So if I'm going down the y-axis and I'm going down my function, I run into an arrow, and this slanted arrow tells me that I'm going to keep going down. I'm not concerned with the right movement because the direction of right is not the direction of a range. It's up or down. So since this goes down, it tells me it's going to negative infinity, which means I cannot draw a down boundary. So now I'm going to go how far up. So I'm going to travel up my y-axis, and as I travel up the y-axis, I'm going to travel up the graph line. And again, I run into an arrow, and this arrow is telling me I'm moving in two directions. I'm moving up while at the same time I'm moving to the right. And the direction of up is the direction I'm concerned with because, again, I want to know how far up I go because that is the direction of the y-axis, which is another word for range. And it's going to go up until positive infinity, so it's not going to stop. So if I'm using every y value going down and every y value going up, that means that my range is all real numbers. I'm using every y value on my number line. I will not leave any numbers out. Now, just like with domain, you can write out all real numbers, or you can use the real number system abbreviation, which is the bolded R. And what does all real numbers mean? It means that every y value is used. There are no values left out of our y list. But again, we are not going to list them out because I do not want to list every single number from negative infinity all the way to positive infinity. That list would just be incredibly too long. All right, so now let's look at how do I find the domain and range from a word problem. So remember, your x values are going to determine if your function is continuous or discrete. And you have to look at your x values. What are they? What are those quantities? If your quantities are being measured for your x values, it's going to be continuous. So we've got a problem here. Winnie is driving at a constant rate. It takes her 4 hours to drive 232 miles from her home in Dallas to her parents' house in Houston, Texas. She creates a graph of distance versus time for the trip using the equation d equals 58 times the value of t. So the first thing I want to do is you want to recopy your equation if they give you one. Now, you're going to recognize an equation because you are going to see the equal sign. That equation is going to be helpful to you because now you can identify your domain. So now I'm going to ask myself, which variable is x in disguise? Is it d or t? And hopefully you said t. You would be correct. This is really x. And I want to find out what are the x values, the t values referring to when I go and I look at my problem. Well, if you notice, we have the unit of measurement hours, and we also have the unit of measurement miles. And I'm going to make this really simple for you. Time, it doesn't matter what you're measuring your time in, hours, minutes, seconds, days, weeks, years, months. Time will always be x. So these are going to be time values. If it is a number that is telling me the number of hours, then I'm going to plug that in for x, which is really being plugged in for t in the original equation. Now I want to ask myself, is time measured or do we count time? And hopefully you said measured because time is measured. And since time is measured, my domain is continuous. Again, I did not talk about my y values. I only referred to my x values. And because we're talking about the quantity of time, it's measured, which means I need a tool, a clock, a watch, a timer. It's going to be continuous. I'm not going to skip through any times. We cannot skip over time. It has to happen naturally, and it has to flow in a continuous manner. You can't skip time values. We can't go from 1 hour and then skip over to 2 hours. We have to go through 1 hour and all of the seconds and minutes to get to 2 hours. So now that we know that x is time, I'm going to go to my table here, and now I'm going to start filling in my values. So I want to know, what numbers can I not include for time? Well, obviously negative. We cannot measure negative time. So what's the smallest amount of time I can have? And hopefully you said 0. If you said 1, I would ask you, can I have time values that are less than 1 hour? Yes, I can have 30 minutes, I can have 15 minutes, I can have 30 seconds. So 0 is the smallest amount of time, and that's going to mean when Winnie is at home. If Winnie has not started her trip, if Winnie is still inside sitting on the couch watching Netflix or Hulu, then her trip hasn't started yet, the timer has not started, and therefore it is 0. And now we're going to pretend that we are measuring all of these time values just past 0, so all those minutes and seconds, and we're going to see what is the biggest amount of time that I can have in my problem. And it says it takes her 4 hours. 4 hours. That's how long the timer is running on her trip. So when she hits 4 hours, Winnie has now reached her parents. So Winnie at parents' house. Okay, so her trip can be any time amount from 0 to 4. It's also going to include these values. So if her time is not 0 or 4, it's sometime in between those, that is when Winnie is on the freeway heading south towards Houston. All right, let's look at a sketch of the graph. If I'm using only positive x values, that must mean I am using quadrant 1. So now I know I'm going to go out to 4 on the x-axis, and I'm starting at 0. So can I include 0 in my list? Yes, because Winnie's trip may not have started yet, so 0 is included. 4. Does it include 4? Yes, because at 4 hours, her time has ended. It did not say it takes her less than 4 hours. So I am going to include 4. I need a close point. And the reason why I put my points kind of going up is because as she drives, as the time passes, her mileage is going to increase. She's driving further away from her house. So because I am measuring time, it's continuous, and I have to connect my points. I'm going to connect, and now I can draw my boundary lines. So this would be x is greater than 0, and I need a bar. Draw my boundary line. This is going to be x is less than 4, and because it's a closed solid point, I need a bar. And so now I'm going to take my two inequalities that we just got done talking about in the last video, and we are going to combine those for my final domain answer. So it's going to be 0 is less than or equal to x is less than or equal to 4. And now, because I have figured out what all my x values are, I can now use those to figure out my range. So now I'm going to go back to my equation. Well, if t was x in disguise, that must mean that d is y in disguise. So I just got to figure out, what is d referring to? What are those d values really? What are those quantities? And we said we were talking about hours, and we already identified those as x values, so miles has to be y. So these are miles values. Okay, so now I'm going to add these. So this is time, and miles has to refer to distance. And now I want to figure out what my distance values can be. Well, if Winnie hasn't started her trip, has she gone any distance? And the answer would be no. But here's what I'm going to do. I'm going to use my equation, because if they give you an equation, you can use this to find your x or y values. So what we're going to do is we are going to plug in our x value into our function rule. And I'm going to plug in 0 for time. And I'm going to do the math. What is 58 times 0? That is equal to 0. And again, we're going to have all of these distance values. I can't calculate all of these distance values because, again, we did not list out all of our time values, but we're going to go ahead and just see. When I stop measuring my time, can I figure out what my maximum distance is? Because my maximum time is 4. And just like we did with 0, I'm going to use my function rule, my equation, and I'm going to plug in my x value. This time my x value is 4, and I'm going to do the math. What is 58 times 4? And it is 232. So my smallest amount of distance is 0. That's how far down on the y-axis I go, and as high as 232 miles. So we're going to add these values to our y-axis. So there's 0, and then my point went up here, so that would be 232. And now I'm going to draw in my boundaries for range. So how far down? It goes as far down as 0. So that's going to be y is greater than 0, and because I have a closed point, I need a bar. And now I'm going to draw in my boundary line. How far up? I go 232 up on the y-axis. So I'm going to say y is less than 232. And again, closed solid point. So I need a bar, solid line bar. And now I'm going to take my two inequalities and I'm going to combine them together for my final range answer. And that would be 0 is less than or equal to y is less than or equal to 232. All right, let's look at how do I find my domain and range if I do not have an equation. So I have Mrs. Love needs to fill up her SUV with gas to drive to and from BMS every day next week. Gas costs $2.58 at Racetrack, and her SUV holds a maximum of 16 gallons. What is the domain and range for this function? Okay, I did not see an equal sign, therefore I did not get an equation given to me, so now I need to figure out what info do I know. And hopefully you said that I'm paying $2.58 per gallon, and I have a maximum of 16 gallons. That's what I know. My next thing I need to figure out is I need to figure out what my x values and my y values are either counting or measuring. So I'm going to make a table of values. So I told you in the problem before that if you are given time, time is always x. Well, we didn't get time. We've got dollars and we've got gallons. Those are my units of measure. No time. So therefore, one of these has to be x. So when you go to a store like Walmart or Albertsons or Quickstack, do you get your total cost for your items, or do you have to bring those to the cashier first before you are given your total cost? Hopefully you said you have to purchase items before the cashier will tell you your total cost. So I'm going to give you another helpful hint. Just like time is always x, cost is always going to be a y value. So cost, dollars. Okay, total cost is always going to be a y value. So if dollars and cost is our y, that must mean that gallons is our x value. I've got to know the number of gallons of gas before I can get the cost or what I'm going to pay Racetrack. Okay, so let's talk about gallons. Do we measure gallons or do we count gallons? Since gallons can be broken down into smaller parts, we measure them. Okay, with a tool, you're going to use a measuring cup to measure out your gallons. So this is going to be a continuous graph. Okay, so I'm going to write that over here. Gallons measured So we know that my graph is going to be connected because my domain is continuous, which means when I write my domain and range, I have to use less than or equal than signs. Okay, so let's talk about gallons. What's the smallest number of gallons I can have? Hopefully you said no negative numbers, but I can have 0 gallons. If I have 0 gallons being filled up, that means no gas yet. I have not started pumping gas into my SUV yet, so therefore I have no gallons of gas being purchased. All right, and then if you've ever watched a parent or a guardian get gas at racetrack, you see that readout on the screen is just counting continuously. So quickly. It's going through all these numbers. Just like time, it's not skipping over any numbers. So we're not going to start listing all those gallon values that we could have. We're just going to see what is the maximum number, the highest number of gallons I could have. And hopefully you remember that we were told I have a maximum of 16 gallons. So 16, that is the most gallons I can put in my car. So max gallons for gas tank. I cannot put more than 16 gallons of gas in my gas tank or else it's going to start overflowing, which is not good. All right, so let's sketch a little graph. Since we are using only positive x values, we are going to draw the first quadrant again. And my lowest is 0, and since I can have 0 gallons included in my list, I'm going to make a close point at 0, and I'm going out to 16. Which means that if I put 16, that means my cost is going to go up. And I can put in exactly 16 gallons. And since it's continuous, we are going to connect our graph. And now we're going to draw and sketch our lines. So here we go. We got x is greater than 0. And we should put a bar because we have a closed point. Here we go at 16. X is less than 16. And we should have a bar because, again, we have a closed point. So when I write my domain, I'm going to have 0 is less than or equal to x is less than or equal to 16. I can have any gallon between 0 and 16, including 0 and including 16. All right, let's talk about cost. So again, I don't have an equation to plug in like we did in the first example, so I'm just going to use some common sense math. If I have $2.58 times each gallon, that's going to give me my cost. Well, the first one here, I have 0 gallons of gas. So what is $2.58 times 0? That would be $0. It's my lowest value for Y. And just like with cost, I'm going to be able to figure out my cost no matter how many gallons I have. But again, I want to figure out what my highest cost is based off of my highest gallons number. So I'm going to kind of use this again. I'm going to say $2.58 times my gallons, and my gallons is 16. And $2.58 times 16 is going to be $41.28. That is the most that I will spend on gas. So I'm going to go over here and I'm going to say 0. And the highest up we can go is $41.28. So now, I'm going to draw in our boundaries. Y is greater than 0. And since we can include 0 in our list, we're going to have a bar because we have a closed point. And now I'm going to say how far up the y-axis we can go. We can go all the way up to $41.28. So I'm going to say Y is less than $41.28. And I'm going to put a bar because I have a closed point. And now I'm going to rewrite both of these inequalities to one final range answer. So I'm going to have 0 is less than or equal to Y is less than or equal to 41.28. And that is how you find your domain and range from a word problem. You have to identify what your X quantities are, what your Y quantities are, so that you can determine if it's continuous or discrete. Start making a table of values and then maybe make a sketch of your graph, draw your boundaries in, and then you can write your domain and range just like we've been practicing.